Today we're going to talk about section 10.1, which is on square root functions. In fact, all of chapter 10 is going to be all about square roots and radicals. But today we're specifically going to look at the graphs of square root functions. Okay? And there's the parent function of a square root graph. Okay, y equals the square root of x. And let's see what the graph of a square root function looks like. So we're going to use calculators quite a bit today. So I'm going to type in the square root of x. Okay? And I'm going to press graph. Here's what it looks like. So it's a little arc. Okay? And if you look closely and carefully at that, the starting point, or the ending point, however you want to look at it, is right there at the origin. Okay? And this point is what I call the vertex. Its vertex is right at 0, 0. Okay? And you notice it kind of arcs up and to the right. Well, when we graph these today, you're going to have to put points on this graph. And where do we get those points from? The same place we've always gotten them from. We get them from the table on our calculator. If I press second graph, okay, and I go right down here to 0, 0, there's my vertex. Well, first of all, what's this stuff on the right here called error? Why is it telling me error there? Well, what if I let x be negative 1? If I plug in a negative 1, it'd be y equals the square root of negative 1. Well, we can't do square roots of negative numbers. For all practical purposes, for what we know, it doesn't exist. So that's why any negative number, any number less than 0, is going to be an error. Okay? And that's why it only works from 0 and everything to the right. Okay, but there are a couple other points on here. There's 1, 1 is on there. Over 4 up 2 is on there. And then, like, how many points do we need to have on our graphs? Well, we want to have as many as we can. And usually we go until we find the numbers that are kind of, they go up to about 10, because that's how big our graph paper is. And there's another one, over 9 up 3. But generally speaking, we should have the vertex, and I would say at least one, or I'd say at least 2 or 3 others, actually. But the table on your calculator is going to find those for you. Okay? And once we get them on there, then we draw them and connect the dots. And just so we're all crystal clear, there's still a few of us that are not putting the points on the graphs. Well, you're not getting credit for your graphs if you don't put the points on there. It's really easy to find the points. They're right on the table. Just copy them down. Okay? How about domain and range? We know that the domain deals with the x values. And the x values go left and right on the graph. Well, where do these start? It starts at 0, and it's everything to the right of 0. All the x values go to the right. So all the x values are greater than or equal to 0. The range, we know, talks about how high or low the graph goes, and those are the y values. Well, once again, where does it start? It starts right there at 0, and all the y values are greater than 0. Okay? So there's kind of the graph of a square root function. Okay, it's a little arc. Okay? It has a vertex, and this particular one is right here at the origin. Okay? And then we can get the points from our calculator. Okay? Well, taking this a step further, kind of like we did with parabolas and quadratics in the last chapter, or a couple chapters ago, we have the general form of a square root function, and it looks like this. And I think you might recognize a couple of those letters, the A, the H, and the K. And the A, the H, and the K are going to affect square root graphs exactly like they did with parabolas. Okay, and I'm just going to write these down here, and then we'll take a look at a couple. The H, if you remember, shifted the graph left or right. It shifted the vertex and every other point on the graph left or right. And there was something special about the H. It was the opposite of what it looked like. And like I said, we'll experiment with some of these here in just a minute. K shifts the graph up or down. If it's a positive 3, it's going up 3. A negative 2, it's going down 2. And then the A here also affected the graph. If A is greater than 1, it was called a stretch. If A was less than 1, it was called a shrink. And we'll see what a stretch and a shrink look like with square root functions here, like I said, in just a minute. And then if A is negative, okay? If A is negative, just like with parabolas, when it's negative, it shifts it down. Okay? And, so let me get rid of this here a second. If A is negative, it opens down instead of up. Instead of arcing up, it's going to arc down. Okay? So I'm gonna look at a couple here. Okay? Scoot this up. Okay? Let's look at this one. Y equals the square root of x minus 2. Okay? Now again, if you look closely, the h is negative 2. It doesn't look like it has a k, but it's a 0, and the number in front is 1. Okay? And this is exactly what your homework assignment is going to look like. It's going to have you answer these questions and make a graph. I should have put this one first, but B is probably the best place to start. Did it get shifted anyway? Well, x minus 2, the h there is a negative 2, and we know that the h is the opposite of what it looks like. So it's going to go right 2 and then up 0. So it really just got shifted to the right 2 units. Right 2, up 0. There's the vertex right there. And by drawing it on the graph, we just labeled the vertex. 2, 0. Okay? Was there a stretch or a shrink? Well, I look at the number out in front, A. If A is bigger than 1, it was a stretch. If A is less than 1, it's a shrink. What if it's equal to 1? Then there was no stretch or shrink. Okay? A reflection? And again, I didn't look at this before, but we talked about opening down if it's negative. Is the number out in front negative? No. So there was not a reflection. Okay, so I can actually answer all 4 of those questions without actually touching my calculator, picking up my calculator. Okay? But speaking of the calculator, that's the next thing we're going to have to do here, is we're going to have to graph these. So let's pick up the calculator, and there's a little knack to this too. Okay? I want to type in the square root of x minus 2. So I'm going to do the square root of x, and notice the 2 is also under the radical. And if you have an older calculator like mine, when you hit the square root button, it's prompting you with a parenthesis. What do you want to take the square root of? What's under the radical? Well, the x and the minus 2 are both under the radical. So I keep the 2 there, and then I close my parenthesis, and that's telling me that's all I want underneath the square root. And you could type plus 0, but I don't need it. But the 2 definitely needs to be in there. You guys with newer calculators, when you hit the square root button, you keep typing, that bar just keeps getting longer, so everything is under the radical. Okay? But I have it here. Let's press graph and see what it looks like. Does it look like the vertex is at 2, 0? That it got shifted to the right 2? It sure does. Okay? Now once again, don't just draw an arc. We need points. If I go back to my table, and I was like finding the point 2, 0, and notice again, anything to the left of it is an error. But there are a couple points. There's another one, 3, 1. Over 3, up 1. Over 6, up 2. Now let's see if there's one more in there before I get up to 10. Well, the next one is 11, 3. Okay, I guess here's 11. 1, 2, 3. I guess I could put that on there if I wanted to. And then I connect them with an arc. But once again, just so we're all crystal clear, make sure I can see the points on your graph. And there we have it. Okay? So there's one. Okay? We're going to take a look at another one. We're going to take a look at about 3 of these. Okay? How about this? Oops. How about that? Okay? Let's see if we can answer these questions. Were there any shifts that took place? Well, this time it doesn't have an H, so it didn't go left or right at all, but there's a K, and the number at the end, the K, tells us it went up 4. So this one just went up 4 units. Okay? And so it's over 0, up 4. There's where it is. And actually, I just found the vertex. Over 0, up 4. Was there a stretch or a shrink? Well, let's look at the number out front. It's 1/2. And don't mind the negative. Let's just look at the number out front. 1/2. 1/2 is less than 1. And when it's less than 1, that means there was a shrink. Okay? A reflection. Was there a reflection? Is the number out in front negative? Yes, it is. So there was a reflection as well. Okay, well, let's see what a shrink looks like. Okay, let's type this one in. Here we go. Now again, be careful. How do I type in negative 1/2? Fractions always have to be in parentheses. -1 divided by 2. And then comes the square root of x. And notice I only want x under the radical. The 4 is outside the radical. So how do I tell my calculator that I only want x? If you have the parenthesis that comes up, I close the parenthesis, and then the +4 comes afterwards. You guys with newer calculators, when you type in the x, you have to press the right arrow so it stops doing stops doing the square root function, and then add 4 afterwards. Okay? And what a shrink does, okay, it's kind of hard to tell here, but it's opening down, and it's a lot flatter. A shrink makes it smaller. Okay? And we need some other points here. If I go to my table, I should be able to find 0, 4 on here. Yep, there's one. Okay? Here's another point, over 4, up 3, right there. And let's see if we can find one more point somewhere. Looks like, oh, they get to be kind of big, but what could I use? Could I use that one? Can you use some of these decimal points? You sure can. I look for the 0.5s, the 0.75s, the 0.25s. But over 9, up 2.5. Up 2.5 is at 2.5 right there. I like to always get at least 3 total points. And this time, because it's a reflection, you can see it's arcing down, just like that. Okay, so a shrink means it's flatter. Okay, and there's a second one. Okay, we're going to do one more here. How about something like this? Oops. Oops, hang on. Let's do this one. +2. How about that? Let's tie it all together here. Does this one have any shifts? Okay, does it have an h and a k? Well, there's my h, and there's my k. And if you remember, h is the opposite. So instead of -1, it's going to go to the right one, up 2. Okay, so I'm going to describe it by going right 1, up 2. And when you describe these shifts, make sure you give me a number. How much did it go left or right? How much did it go up or down? Okay, and by doing that, by going right 1, up 2, we actually just labeled the vertex 1, 2. So again, questions A and B, they kind of go hand in hand. They go together. Was there a stretch or a shrink? We'll look at the number out front. 3. Is 3 bigger than 1? Yep. So this time it had a stretch. Oops. Okay, and we'll look at what a stretch looks like here in just a minute. And how about a reflection? Is the number up front negative? Nope, there was no reflection. So it's not going to open down, it's going to arc up. Okay? So we've got all those questions answered. Now we've got to type it in the calculator. And again, be really careful with this. And how you type in is probably the most important part. I'm going to type in what I read there. I have 3, then the square root, and what's underneath the radical here? It's both the x and the -1. So x minus 1. I'm going to close my parenthesis because that's all I want the square root of. Or press your right arrow so it stops doing the square root. And then the +2 has to be outside of the radical. And if I press graph, does it look like it got shifted right 1, up 2? Right 1, up 2. The calculator is a very easy tool to check your answers. Okay, we need some other points here, so I'm going to go to my table, second graph. Again, I'm going to go find my vertex right there. And there's a couple points. There's 2, 5. Over 2, up 5 is right there. Over 5, up 8. It's going to be up there. And is there any others? Up the next one. Well, 10, 11. I guess I could put that on there. Over 10, up 11 is way up there. Okay. Start at my vertex. Connect the dots. And away we go. Okay. And what does a stretch do? Okay. A stretch makes it steeper. Okay. It arcs it higher. If I had a 4 out there, it'd be higher yet. A 5 would be higher yet. A 6 would be higher yet. Okay. But there's a look at the graph of a square root function with the a, h, and the k all in it. Okay. Here's a little word problem. Let's take a look at this for a second. Okay, the Golden Gate Bridge. they talk about the velocity of a free-falling object right over here is 2 times g times h, where g is gravity, 9.8 meters per second, and h is the height of the water. Okay, if it's dropped from the bridge, that's 67 meters tall, what's its velocity? Well, you can see they just plugged the numbers in for g, h. Under there, the radical, they took the square root, oops, get that thing out of there, about 32 meters per second. Okay, so just typed all that in, took the square root of it, not too big of a deal. Okay, can we try a word problem? A tsunami travels fast. Its speed is given by this, where the speed is 3.1 times the square root of the the depth of the ocean. Okay, so the deeper the ocean, the faster the tsunami. Okay, let's graph this on the calculator. Okay, I'm going to do x equals 3.1 times the square root of x. Okay, and if I graph it, there it is. Okay, notice that, where's this vertex? Where does it start? There is no h and there is no k, so its vertex is kind of right at 0, 0. What is the speed of the tsunami if it's 26 meters deep? Well, there's a couple different ways we could do it. We could type in a 26 right here, or I could go to my table and I could go down to 26. What if x was 26? There it is right there, about 15.8 meters per second is the speed of that thing. Okay, and just out of curiosity's sake, if I did type in 3.1 times the square root of 26, we get the same answer, 15.807. Okay, so word problems aren't a big deal. We're just going to plug in the numbers. Okay, but the main nitty-gritty of what you're doing today is we're going to use this general form of the equation, the a, the h, and the k to find the vertex, to find the shifts, determine if there's a stretch or a shrink, and then determine if there's a reflection, and then ultimately put it all together to answer those 4 questions. All right, thanks for tuning in.